Today we'll be walking through the Sunrunner app. On this screen, we can see the landing screen. This is where people would arrive if they first arrived at the app. Next, we can log in. The login screen brings up a spot for an email and a password for a pre-existing user. You can also see the navigation bar on top. For our login, we will be using a login that we prepared previously. So, once we log in, the server will be contacted and will be directed to the activity page. The activity page is where each of the activities for the user will be displayed. Here we can see two activities, each occurring on the same date, with different durations, distances, and various other properties. From this higher level view, we can click into the detailed view. The detailed view holds more details about that certain activity. Here we can see, using cards and bootstrap objects, overall summary of the activity. Again, we have the date, duration, and those various properties. Right here we can see the path that the user took during their travel, right around the U of A. And then on these graphs we can see the speed and the UV index during the trip. We can also see the activity type that the user was doing during that time. If we click these buttons on the side, we can switch that user activity. This also shrinks down nicely. As you can see here, it goes from a wider detailed view for something on a big screen to something that can be easily seen on a tablet or a phone. Going on, we go to the summary page. The summary page holds information for both the user themselves and for the local and total user activity. Here we can see the duration of the user's activity in minutes, the calories burned, and the overall UV exposure. Looks like our UV exposure was a little high compared to the global averages. On the local and global scale, we can see the additional activities from the other users and the average total distance and calories burned. Next, let's move on to the weather page. The weather page uses a third-party API through the server and retrieves information about the highs, lows, UV index, and humidity for the next few days. Here we can see today, tomorrow, Friday, Saturday, and Sunday, a 4-day forecast. Or no, 5-day, I'm sorry. Finally, let's go to the profile page. Here we see the basic account settings, devices, and other general information that the user might want. Here at the top we have the current information for the user that can be realistically changed. Then we can enter in account information and change it that way. Moving on, we have the devices that the user is currently using. We have the option to delete them just in case they want to get rid of them. Here we have the option to add a new device. So by adding in a device ID, let's just have this one, you can generate an API key that will be used in your device. Next, we have the UV level setting. This is the UV exposure level that the user will be alerted at if it passes that. So here we can change it, but this slider bar doesn't do anything until we update the limit. And then, as we can see at the top, it says we've successfully updated the limit. Don't delete the account. And finally, when we're done with our use of the app, we can log out, and that will return us to the main page. Over here, we can also look at the sign up. In the sign up, there's a couple different things going on. First, of course, there's the email, password, and password check. To ensure that the user can create a strong password and email, I've placed restrictions to tell if the user has done the suggested recommendations for the password. So, to have a secure password, it must be between 10 and 20 characters, have a lowercase letter, uppercase letter, digit, and then also match the one below. So let's try it out. see up at the top, we can see that a verification email has been sent and that now we'll be ready to log in. A nice feature is that it'll automatically log in after the sign up. We don't have any data yet, but that might change soon. Thanks for listening. Here we can see the main JavaScript file for the entire app. The reason that one JavaScript file was chosen rather than several is to reduce the amount of HTML requests that had to be made. Here we can see that through the use of body has class, the JavaScript has been separated out. So let's quickly run through it. The landing page doesn't do much. It just has to implement 2 buttons to direct it to other pages. The login page itself doesn't seem to do much. It just logs to the console, takes the email and password values, and then passes them into the login function. The login function, which we'll see later, does most of the work. Next is the sign-up page. The sign-up page implements a listener on the button that takes the email, password, and password check, runs it through the checker function, and, if the password is good, signs up the user and moves on. Next, this is the, where are we? Next we have the activity page. There's a lot of code on this page. First, before doing anything, we have to load the data. This is a GET request that uses a token and grabs the data from the user. It then takes that data directly, computes activity stats, which is a function that we'll see later, and then through the use of jQuery functions and access, puts the data into the web page. It also runs 2 more functions to plot the speed and plot the UV. In this section, there's also a refresh and a back button, as well as the walk, run, and bike buttons. Finally, this is where the app from the Google app was implemented, and the Google map was put onto the web page. Next, let's go to the account profile page. So in the account profile page, it's mostly setting up buttons. Here we have the Edit Settings button, which allows the settings section to toggle on and off so you can save space. If the settings are changed, then it takes from those values, sends a post request to the server to update those values, and then informs the user that they've been changed. Next, there's a device changeout, and that essentially is a wrapper for this feature here, which just sends a device ID and an old device ID and switches them out. Next, the UV slider is implemented. Here we have the feature that actually allows it to slide, and then when the update UV button is pushed, then there's an AJAX call that sends that data to the server. The weather page got a little bit complicated because of the need to do dates, which were not provided in the API. So there's a section to implement the dates. Then, with the results of the weather object, which is the data from the call up here, the script goes into each of the sections and puts that information into the cards. Next, we have the JavaScript concerning the summary page. The summary page was mostly just a couple wrappers for calls to the server and then inputting the data back into the web page. So here we have the call for the local data. It grabs it, processes it with the compute activity stats, sums it to keep it running sum, and then outputs it to the screen. The local ones are much the same. It takes a local retrieve call, processes it with the compute activity stats, and then logs it into the screen. Finally, there's the global retrieve, which takes the global data, follows the same process, computes it, and logs it in. To enable those functions and segments above, there's a few functions that are useful. Here's the login function, which wraps the login call to the API. We also have a similar one for the sign up endpoint. The password email check is a re-implementation of what we did earlier this semester, and it uses regex and several other things to check to make sure that the password is correct. The plot speed and plot UV are the canvas functions that turn the data into the graphs. And finally, for compute activity stats, the data would be fed into this function that had already been pulled from either the user, local, or global information. Then this code here just goes in and calculates several important things such as duration, distance, calories, UV, speed, the whole number of those things. And then it outputs that information back as an array, so it can be used in other ways. One quick further comment on this section here is that this area here uses the distance and the activity type to compute calories. It uses a ratio based off of what can roughly be seen in real life functions, or the Bootstrap JavaScript script, as well as the Google one and the Canvas one. Here we can see the viewport, preparing it for mobile use, the nav bar, and now we go into the overall view for the activity page. Here we see the columns used to prepare for Bootstrap. And then we can see here in the detail view, which is hidden at first, we can see the columns with several different dimensions and sizings based on how big the viewport is. This is something that pops up throughout the code as we go through it.
For the IoT device implementation, we are first going to explain how we did in the code for each requirement. Then after that, we will run the code on the device to show how it works. So in our code, we have the IoT.ino, which is set up where pop show data to the webhook, and then we have two .h file and two .cpp file to implement the state machine. So we use the setup button on the device as the power button. We connect an extra button to start and stop the activities. Right now we set the recording rate to be once per second. And for the UV threshold, here is how we pull the data from the database, then set the alert for the UV when it's greater than the user-defined threshold. So if we go to the statemachine.cpp, we can see we check the UV threshold, and then if it's true, it's greater than the user-defined threshold, we'll set the digital write to write on our external LED to be high. And here is how we implement the storing data for 24 hours if there's no Wi-Fi connection. So in our data, we will set the event time and calculate based on the event ID. If it is not true, we'll store the data just on the local device, and then after, if there's Wi-Fi, we'll publish to the server after it. And right here, there is a state for the pause. So if the speed is 0 for over 30 seconds, we checked it, and if true, the device will stop the feature, and on the serial print, we will print the pause statement on it. We will show it later. And for the sensing data, on the photon device, we set the LED will blink five times in a half seconds once while it is sensing the data, and after it will blink delay for 1.5 seconds. Then LED will set to be high, so it shows that we are uploading the data to the database. Okay, so this is how we set up the device. This is our power on and off button. And the extra button we use here is to start and stop the activities. There are 3 LED on our device. The red one will be on when the UV alert is on. So like when the UV value is greater than the it's greater than the user defined threshold, the red LED will turn on. The green LED indicates the power of the device is on or off. And the yellow LED will turn on while it is uploading the data to the server. Right now we flash the code and we open the serial monitor. So if I place like the start button on the device, it shows like the power is on, and the green LED is on, which indicates like the power is on. So we start the activities, which is going to start sensing the data. And we can see like incremented like as like we record the data once per second. And you can see the LED light on the device is blinking like 5 times in half a second. So after 30 seconds, since the speed is 0, it prints out a pause statement. So I'm going to press like the stop button on the device. And it shows like the yellow LED is on, which is uploading the data, as right here. It just send the data to the server. And if we press like the start button again to record a new activity, it start recording again.
So I'm going to be going over the backend implementation of our web server. It's going to be kind of a pain considering, backend is mostly code. It's a little bit harder to visualize than, say, the front end or actually dealing with the device. But I'm going to give it my best shot. So as per the requirements of the project, our server was implemented with Node.js, Express, and MongoDB at its core. And then it was there was quite a bit of additional modules added on in order to accomplish a variety of tasks. So I'm gonna try to dive in and go through these as quickly as possible. First, I'd like to start with how I actually laid out my schemas. Most of them are pretty simple. So this is just a simple device schema. What it's here to do is literally just store the devices, their ID, the user email that owns them, and their API key. A user, which stores an email, the password hash. There's an isVerified, which deals with the email verification system. A UV threshold, what city they live in, and then an array of all their devices. And finally, one of the things that comes up the most is the data schema. So we have the API key of the device that actually posted the data, the user email, and then the activity. The activity array is an array of objects. These objects consist of things like the temperature, the humidity, things that shouldn't change over the period of an entire activity, such as what type of activity it is, whether it's walking, running, or cycling. And then inside there is another array containing all the data, such as the speed, the location, the UV index, and so on and so forth. And finally, there's a verification token schema, which uses the user ID that is basically it's the MongoDB ID for each user to mark them, creates a token, and then sets it to expire after an hour. And this is just used to keep track of basically it keeps track. It's a way to allow them to verify as well as to let the verification expire. So now moving back to we'll start in data because it's a little bit smaller than the rest. So we have Express, we have links to our various schemas. I used request to handle the weather API calls because I was having some difficulty trying to get jQuery running server side, and I found that request was very simple to use. We're also using FS, which has to do with the secret key. And then, sorry, lost my train of thought. And also Jot Simple, which also deals with dealing with authentication token. So starting off, we have Retrieve, which just takes in that authentication token I was just talking about, and basically uses that to find out who's actually asking, and it returns. It'll actually return all of their data. We have a Log, which takes in the API key, and basically tries to find. So what it'll try to do is it'll find the device to be able to get some of its info. It'll go through and take the data that was passed along with that. Calculate things like average speed to be able to figure out what kind of activity it is with the type, some if statements. Right here we have the request handler, and this is what's actually going to the dark sky API to get our weather. Going through, filling out all that. Again, here's what I was talking about on the activity, where we have the type of activity, the temperature, the humidity, and an array containing the activity data. And then finally, we use the update one call, along with set on insert and upsert true. So basically what this means is if there isn't any data, or if there isn't activity yet, it will generate one. Whereas if there isn't activity already there, then it will simply update that activity. We have global retrieve, which literally just takes all of the data and sends it back. And then local retrieve, which again takes the XAuth. It goes into the user object and figures out which city they're in, and finds all users in that same city, and then loops through them to find their data, pushes that data onto an array, and then sends it back. And then finally, activity. This allows the front end to be able to change the activity by taking the activity's index in the array, and So this one's the activity endpoint. So it basically takes in the index of where the activity is in the array, as well as what activity you want it set as and the user's email, and uses that to update it. Moving on to devices, let me scroll back to the top. Again, Express, the various models and schemas we have to use, FS and Jot Simple again. This one also uses the function that we used in class to generate an API key. So we have a post to actually register a device. Again, this takes the XAuth header, like most things will. It also needs a device ID, which it'll then, after it's checked the authentication token, checked for the device ID, it'll run that through and see if there is already one. If there isn't, then it will add it. So right here, it fills in the device, gives it sets the device ID, the username, and the API key, saves it. If there's an error and then else, we go into user and we update their user devices array. That way we can just have them linked together fairly well. Here's the replace endpoint. This is used to go in and replace one of the previously registered devices with a new one. So it's very similar, taking an email, a device ID, and also device ID old. Most everything's the same, except when we get into here. So it'll actually go in and update a device instead of creating a new one. And so it does things like checking to make sure that the old device ID is actually a device, and then going through and updating with the new device ID if it's not already in use. And finally, we have a get method for the UV threshold. This way the device can have a simple access to it, so it just does a simple get and it returns back the UV threshold for the user. Finally, the longest one that I'm going to try to speed run through. Express, schemas, FS, bcrypt.js for the password hashing, Jot Simple again. Again, request because for the dark sky API for the weather. This one also uses crypto to generate the verification token. Node mailer and node mailer send grid transport. So what node mailer allows us to do is actually send emails fairly simply from inside the JS, and this node mailer send grid transport is their web API version, which just made it so much simpler to implement. So starting out with the sign in. So first we check, okay, is there a user with that email? We handle errors. If there's no user, if there's no user, email or password invalid. If the user's not verified, sign in, user find one, email passed in the body. If there's an error, we say what it is. Else, if there's no user, then the email or password is invalid, which again would be what's returned here for the bcrypt if it doesn't work properly. There's an error that they're not verified. Then if they are verified, then we go through bcrypt.compare. If it errors out, error authenticating, please contact support. Else, if valid, give them a authentication token and return. Else, their password was wrong. Here's the user registration endpoint. We start off by hashing the password that is passed in the body. If there's an error, we error out. Else, we generate a new user. We save that user. If there's an error, we handle it. Now we actually create a new. After we save the user and make sure there's no error, we attempt to create the verification token and use that. And so here, known mailer comes in. So we have the known mailer, and finally the transporter.sendmail actually mails it out. Can handle an error. Will display a message that the verification email has been sent, and then return. Confirmation is a really simple endpoint. It's not fleshed out very much at all. Basically, the URL that is the email that's sent is sent with a URL with a query that has the token. I can show it to you. Right. So it has a token, a query that's literally token is equal to the token, and this GET request is literally just looking for that. It's taking the token and basically checking to see if they're verified, verifying them if they're not, and saving it. We have update. This one's quite long. So this one actually updates the user information. Again, this one's based on XAuth. I'm just going to go over this first one because the rest of them are just else if statements that are different combinations, starting with all three, then going down to all combinations of 2, and finally each one, for a total of 7 possibilities. So we just has on property email, password, city, because those are the things that the user can update. If it errors, else, so we go to user update 1. We query them based on email. We set their email to the email, password hash to the hash, and city to the city. And handle errors and return if everything's successful. This is the user UV. This is how they actually set their UV threshold. They do so by making a post request. Again, XAuth authentication, and literally just grabs the UV threshold that's passed in the body and sets it. And finally, we have user_weather.get, which uses the dark sky API again to actually get weather and basically just send it back for the front end to handle. So here's where I was testing a lot of our endpoints using Postman. Here's user register. I can't reuse this one because it will basically tell, or I can go and do it, but so this is when I actually registered my email, my actual Arizona email. That way I could actually reply to the user verification. So it succeeded. Verification email has been sent. When we run this, false, and we get an error message because it's a duplicate. We get an error message stating that the duplicate is trying to be registered here. We have the sign in. This is where we get our auth token. Not much to see here, so I just here is data retrieved. So this is actually retrieving the data for a specific user. So one thing I did forget to mention a while ago was that we have a endpoint layout.txt, which just gives the overview of like the sign in, what queries, what headers, what it needed in the body, different kinds of responses it'll give. I just want to chip back in to mention that we do have that. So one thing I almost forgot to mention is I do have the website set up using Nginx as a proxy and also to handle the self-signed certificate to run the website as HTTPS.